Okay, let's see, we got sound it looks like. Maybe we can move this a little bit. Let me nice this. Let's switch this over. Okay. All right, I think we are pretty much ready. Let me make sure this is paused. Yep, we don't want to hear myself. And let's put the chats back. Okay. Introduction. Hello, everyone. I am Tim. I go by foamyguy on Discord and GitHub and Twitch as well. Although on Twitch it's foamyguy_Twitch. Somebody else had it already. We're going to be working on CircuitPython. Of course, we're filling in for Scott tonight. Normally does a deep dive at this time. If you are brand new, if you haven't caught my stream or Scott's stream before and you don't know anything about what we are dealing with, very brief introduction, circuitpython.org. You can find out more here. This is basically a version of Python that runs on these tiny computers. I have one pulled up here, actually in the camera. This one is a Feather RP2040. So this is basically a tiny computer, and we are writing Python code that runs on this little computer and allows us to manipulate the I/O pins. So we have a series of GPIO pins. We can turn them on and off. We can hook up lights and speakers and, RGB lights and sensors and all kinds of things. And we're able to write Python code that runs on this main chip to manipulate, whatever is plugged into this device. Let's see if we can get just a little more focus on that. Let's see. Nope, this is the wrong way. There we are, I think. Okay. So that is what CircuitPython is about. This one, again, is a Feather RP2040, but there are all sorts of different form factors, shapes and sizes, and, things that are built in, like some of them have screens built in. We use those a lot on my stream. Some of them are smaller, like this one is very tiny, only has like 10 pins. Some of them are circles with nice alligator clips on the outside there. This one is a Neo trellis. It has a bunch of little buttons on the top there that have RGB lights inside of them. And so there's all different shapes and sizes. Feather is going to be the one that we are working with today, but there are many others. If you want to see what all the different shapes and sizes and form factors, as well as all the different things you can plug in and do with them, you can come over here to adafruit.com. This is their website. And I will mention as well for the stream, we are working on the CircuitPython project, which is an open source project, but Adafruit is paying the folks that are working on that project full time. So the core development team, the folks that foster the community and work on the libraries and things like that, including myself, they are all paid by Adafruit to work on CircuitPython. So please, if you would like to pick up some hardware that does this sort of stuff, consider purchasing your hardware from their website here, adafruit.com. This catches my eye. The pink feather is, they're back on, maybe they're back in stock for the special order here. So I think they were out of these for a minute. Maybe they got some more in. This is interesting because the pink feather is actually, this is a pink version of this feather that I have right here, which is actually the core of really what I'm working on today. Obviously, my feather right here is just the plain one. I've got the pink one over in a box in the other room, but I haven't soldered the pins on yet. And we needed the pins, so I wanted to use one that was already soldered up today. But this pink feather is actually the core of what I am working on. So I'll give you a very brief introduction, and then we'll dive in on the CircuitPython side. So what I'm trying to do is make a replica of this feather inside of Minecraft. So I have Minecraft loaded up here. I'm not connected right now. I don't know if it's running, actually. Yeah, it looks like it's not running right now. I think I have a picture. Is this still the picture? Yeah. I imported a 3D model, a CAD model of this device into Minecraft, and what I want to do is try to write a plugin that will hook up all the I/O pins to where they are, in sync. It will keep them in sync with the physical feather that's going to be plugged into my computer, just like this one is right now. And then the Minecraft feather and the physical feather will mirror whatever happens. So inside the Minecraft world, if you put a lever on the pin or something like that, and you flip the lever, it will tell the microcontroller, to send that pin high or low, depending on which way you flip the lever. Conversely, you can have a button, like I have a cherry, keyboard key breakout right here, but you could use any kind of button. You can have this hooked up to the feather, and then inside the Minecraft world, you can set it up where when you push the button, it's going to create a redstone circuit for you. So, it would be just like if you flip the switch inside Minecraft, you can use it to turn on and off your redstone contraptions. So we're still a little ways away from getting all of that stuff put together, but the part that I'm going to work on specifically right now is some code that is going to run on the microcontroller and is going to let us connect to it through serial, and it's going to let us send essentially commands to it. We're going to send commands to tell it which pins to set high or low, and also we're going to have some commands to tell it that we want to read the value of a pin instead of setting it. And in that case, we'll read the value, and the microcontroller will send it back to us over that same serial connection. So that's going to be the code that I'm working on to start out with here. And what do we have running on this right now? This is not the code. Okay, let's go to code. Okay, 7 segment test. I don't remember if this is the simple test or if I modified this. I'm going to keep a copy of it. So I'm going to go here. We're going to rename this one code 7 segment. Make a new code in here. All right. And I actually have the beginning of this script, or what I'm going to base it off of, that I wrote a while ago as an example for somebody on the Discord. So we'll hook this up first, and I'll show you how it works, and then from there it will make sense what we're going to do to change it to suit our needs right now. So one thing I will need to change, this was written for Trinket or an Itsy Bitsy, which has a dot star on board, but we actually have a NeoPixel, not a dot star. So we'll say, I don't know if I know off the top of my head how to instantiate this. Let's see if I get it right. NeoPixel, so we're going to need a pin up probably, which is probably board.neopixel. Import board like this, dir board. Yeah, NeoPixel. And then I think we need like a number of pixels. We have 1, and then brightness, I guess we would need, let's try that for now. Auto write, true. This might be all we need. Okay, so pin, number of pixels, I don't know, bytes per something maybe. We're not using that, I don't think. Brightness we did, auto write, pixel order I don't think we need to do. Star is whatever we send to our parent class. I think we got everything. So we create a NeoPixel. I'm going to put this up here and erase this. Let's make sure it worked. LED 0, we're just going to set it to blue. 0x0000 FF for blue. equals, and yeah, we should just be able to run this, and it should turn the NeoPixel blue. We'll worry about fixing the rest of these things. Actually, it might just work automatically, right? Because we're already setting LED. Maybe this stuff is going to work already, but we'll see. Mostly we're just looking for this to turn blue. So I'm going to move this over here and get this and move it over here and go to the camera. Okay. And it's white right now because we're in the REPL. I'm going to save this. I'm going to break out of the REPL and rerun the code. And yeah, it did turn blue. Okay, so we did set this up right. Let's close that. So some of these might actually work. We might be able to just send red, green, and blue, and maybe this will change. So we're sending it through the serial, which is the same place where we're seeing the print statements right here. So we can maybe get this out of the way. Okay, maybe we can just do red, enter. Oh yeah, okay, so that worked. We can turn it to red by sending it command. And green will be the same. There's green, and we can go back to blue. And maybe color works. So color, we say color space, and then parentheses and a color value. So if we wanted pink, we could do like color. This one doesn't use hex, but instead uses a tuple, basically. So for pink, we could say 255, 0, 255. Failed. Maybe we don't need spaces. And by we don't mean, I mean you can't have spaces because they break it. Yeah, so now we got pink there as well. So this is actually the basic idea of what we are going to be doing. Sending commands through the serial port, making the microcontroller react to those commands how we want it to. Right here, we're setting the color of the NeoPixel, but what we're going to change it to do is to turn the pins on or off, essentially, or set them into read mode where they will send back their values to us. So I'll keep the NeoPixel initialized. Maybe we'll use that at some point. I'm just going to turn it off, though, for now. And let's see. I guess I'll keep these functions for now. I don't think I'll end up using them ultimately, but we might as well keep them for now. So let's think about how I want this to come across the serial. I think I want you to be able to send something like, what are the pin names? The pin names. Let's go here. Let's do this again. Okay. I think I want you to be able to do something like, so you could do like D5 space 1 or 0 for on and off. And this would tell it to set pin D5 to output and then set the value of the pin to either high if it's 1 or low if it is 0. But then if you wanted to read, you would do something like D4 space R. And this would tell it to initialize pin D4, take readings of it every so often, like, I don't know, as quick as it can, basically, I guess. It's going to be a couple of times a second, probably. And then send those readings back to us. Maybe with some filtering like debouncing, so only send it to us if it changed or something like that. And you can basically just send whatever pin you want. So do we need anything more sophisticated than that, or just the pin name and then either a 1 or a 0 or an R? That might be all we need. I'm going to start with that and see if we come up with a need for something else. So I'm going to call this def pin command. And this is one that's going to work more like color, where when we send it, we're going to send an argument. Like we did color and then space and then the argument, which in this case was the color RGB value. The red, green, blue ones, we just sent like, you know, the color by itself. We didn't have an argument. The argument gets passed into here. Oh, you know what though? The thing is that this is different, right? We always start with color and then the argument. This is going to start with different things. We need to do this differently. I think we need to do maybe... I think this has to be like pin. But one thing we don't have right now, I don't think, is multiple arguments. Yeah, we just hard-coded... We hard-coded the arguments. We could maybe fix that, though. What if we just make this a little bit better to where we're not hard-coding the number of arguments? I think I know how to do that. Instead of pin command, let's make def argument test, which is going to take arg1 and arg2, and it's going to print this. Arg1 is this, and arg2 is this. Arg2. So when we read this, what are we doing? This is pretty old code, but there's not much of it, right? Value, so read it from the input, split it on the spaces, and put that into parts. So parts is a list. If the first one is in the map keys, if the length of parts is more than 1, so if it has arguments, look it up out of the map, call the function. These all map a string to a function. Call the function, pass parts 1. So instead of this, we would pass we need to destructure it. I don't know if that's the right term in Python. But we also don't need to pass the first one. I think we should do args is a list. And maybe we should actually just say args is parts. Yeah, and I don't know this. Let's see. It's like we want L is equal to 1, 2, 3, 4. We want 5. That's fine too. We want what? We want all of them except for the first one. So L, is it 1 like this? No. -1? No. Oh, that's 11. No. 1 like this? Yes. That looks better. Okay, so everything except the first one. So 1 colon. So parts 1 colon. Now we have arguments. And then here we do, I think, args star or star args? Stargs? Star args? Yeah. So that's at least not a syntax error. Okay, so yeah, save this, rerun the code, and oh, we didn't add it to the map. Let's add it to the map. Test, args test or whatever, right? Args, argument test. But we don't want to call it, we want to pass it as a function. There we go. So now can we say test hello world. Yes. Okay. So we can pass any number of arguments now. We could keep adding more and more. Our functions don't have to need more than one. Like, does red, green, and blue still work? Red. Yes, does. Blue also, yes. Color, let's make sure color. Color space this. Let's do yellow. Yellow. Oh, spaces. Spaces. Yeah, spaces are a killer. Color, okay. So we could also make a new color command that's like color, 1, 2, 3 with spaces and no parentheses. We could do that if we wanted. Now that we have this. But that's all right. I'm going to leave it for now. So test this works. So we're going to go def pin command. And this takes a pin name and it takes a value. Or should we call this a command? Because it's either a new value or it's a request to read. It could be 3 different things. I think I'm going to call this a command. Pin command. So it takes a pin name and a command. And so the first time we do this, it's not hard. We just initialize it as IO out. Set its value accordingly. But what do we do once we have already initialized it? I think we should make a dictionary. IO pins is a dictionary. And I think we should go if pin name is in the IO pins, then we'll just set it to what we need to. So I'm going to put pass for now, and I'm going to put set its value or start reading. We need to check command and see if it's a 1 or a 0 or an R. But I actually want to do the other branch of this. Else, if it was not in IO pins, then we're going to add it. IO pins pin name is going to be I don't actually know from memory. Code. I could take a stab at it. I probably would get it right eventually. It'd take me a try or two, but we can copy it and get it right the first try. So we want this output, and the thing is we have the pin name as a string. So we actually need to do board get. Can we do that? Oh, import board. Is it get adder board D5? Yeah, that looks right. Okay, so we would say get adder board pin name. We'll figure out what happens if you give it a bogus name. It probably raises an exception we should catch. So we need to import this. Yeah. So we create a digital in out. We're gonna let's go to the docs. So you can do some of this stuff with the initializer, I think. I think there's like shortcuts. You can just pass it like direction and no, this just says pin. direction. Defaults to input with no pull. Switch to output. Value. Drive mode. So we can go. So what happens if you call it a get? Well, no, we have another branch up here. We're not going to call it again. Right. Switch to output. Self value. So we need to figure out value actually. Figure out value. Where do we want to do that? Should we do it before we... Yeah. If command is 1, value true. So we're gonna have value none. Okay, this is 0, then value will be false. And then we'll do something different for R. We'll do like reading, false, elif, uppercase and lowercase, true. We need to store whether or not we're reading. Let's just do writing first, though. So if not reading, we're doing these things. Value is value. Equals value? Maybe we need to do that. Drive mode, we're just going to leave it default. Okay. So in here, we're going to have also if not reading, and then we just set it. We already created it. We already set it to output. We just say value is the new value. Yeah. And we'll deal with reading later. Set the value. That should be good. So now we should be able to say like D5 1 and D5 0, and it should turn D5 on and off. Well, pin D5 1 and 0. So let's try it. Should we use D5? Yeah, why not? Let's ground. How does this work? Long side is positive, is that right? Long side, which one's longer? I guess that one's probably longer. 5. Ground. Okay, so I'm gonna probably have to play with the camera some. I think this is not on right now. Maybe we can do the controls. Let's see. Turn this on for now. Yeah, so right now this LED is not on. Hopefully it's going to be more clear when it is on. We'll see, though. So let's save this. And I just have this connected from pin 5 to ground. Oh, but I did not connect ground to the rail. Let me do that. Ground. Ground rail connected to, boy, this is sure bright. Ground pin. There we go. And this is still off currently. LED, so that's good. Save this, let it run. Okay, so it's still off, which is good. We haven't sent it anything yet. So can we say pin D5-1? So we sent D5-1, does not look like it turned on. Let's say we go inside of here, print inside pin command. You know, I think I didn't put it in the command map actually. Yeah, pin command. We're gonna have to do that for sure. Okay. We should do some of this anyway. Inside pin command. Let's go value this, reading this, format value reading. Okay, this will give us some more information. Pin D5-1. Ah, it turned on. Perfect. Okay, so can we turn it off? Pin D5-0. Yes. Okay. That is exactly what we want. So now we can send it commands to output either high or low on any eligible pin that we want. I guess we should go ahead and see, like, what does this do if we give it something bad? Blanka 1. Failed. That's actually not so bad. Does catch it. Oh, okay. So, yeah, it could be better. What? Let's see where it actually fails. Pin. It has no blink. So it's probably on. When it looks on board. This doesn't give us the full stack trace. But when it tries to find this on board, so we should maybe say, before we do anything, let's say if pin name in how do I get a list of, oh, right, duh, right, that's how I do this, yeah. There'll be some that are still not what we want. Like these it will find them and it's not really a pin and it probably would break something, but it's close enough. We can say dir board, pin name is in the dir board, then do this stuff, else print pin, this pin does not exist. And format pin name. Okay, that's a little better. Right, so now run. Wish I could go up to older stuff. Pin BLI does not exist. Perfect. The next thing it should do, if the pin does exist, it should also do if command is in 1, 0, read. Then do this stuff. Oh. Else print command, invalid command must be one, 0, or R. I feel like I should have quotes on these because they are strings. You don't have to type the quotes, but I think, I don't know if it would fail if you type the quotes. Okay. Format command. Yeah. Invalid command. Maybe this should say invalid pin command to differentiate it between things in the command map. Right, because invalid command you might think is just a thing not in this map, which we have a check for, but it doesn't output it, which we could do else. Wait, what? Why'd it go back there? Yeah, else it's not in the command map, so print. So this one could say invalid command. Must be one of. This is parts 0, and then command map keys. Now if you say like Blinka2, it says invalid command. Blinka must be one of, it's got this thing in it, which is not great, but this is good enough. Color, test, pin, blue, red, green are the commands we have. Ideally, it wouldn't say this. We could make it a regular list or something, or we could hard code it. This is pretty good. Tells us we got an invalid command. Versus if we say pin D5 4, invalid pin command 4 must be 1, 0, or R. Perfect. Perfect, and pin Blinka 1, pin Blinka doesn't exist. Perfect. Okay. So now we can output high or low to any pin we want. So we need to figure out how we're going to do the reading. I think so let's see here. I do think we want to debounce. So I think we want to store the current state, essentially, the last state that we sent, and then only send a new one if it's different from what it was last time. But what do we want to store that in? Basically need a list of pins that are going to be set to input, and then we need the previous state. So I'm going to call these No, I'm going to call these read pin states. This is also going to be a dictionary. So this one's going to have keys that are the pin name and then values that are the last state that we sent. So okay, so if we're going to need basically both of these ones here. If we did not already have this pin in our dictionary, then we need to create it and switch it to input this time. Why? Why is that our indentation? Oh. Right, well, we're going to be on the other side of this. Okay, else. Yeah, that's what we want. If we're not reading, do this. If we are reading, switch to input. And we have kind of an arbitrary choice to pull up or pull down. Doesn't say what the default is. I think we should pull it down and then connect it to high so that value true means pushed. We won't set a value. We will set a pull. So microcontroller pulls it down. Our button will pull it back up. Okay, so we created it. We switched it to input. We're also going to need to handle the case where it used to be on output and we want to change it over to input. We'll deal with in a minute. If we already had it, if pin name was already in our dictionary, else if we are reading, oh, you know what? We need to do something else here. We create it, we add it to the dictionary. We also need to add it to the reading pins, reading pin states. This. States, I think we say pin name and then just get the value the first time. If it's in IO pins, if we are reading, really the thing we need to know is it if pin name is in read pin states.keys. So do we already have it? Let's just say not in. If it's not in the read pin states, then put it in there and switch it to input, because if it was in IO pins but it was not in read pin states, then we know that it would have been set to output before. So switch it to input, add it to read pin states, put its initial value in. We might have a problem where we don't send the first initial state. We'll have to solve that somehow. Let's see. So this should start us a dictionary with our original value in it. So let's say inside our main loop, the first thing we do is read send pin readings. Def send pin readings for pin name in so we're going to loop over the pins that are in the reading pin states. For each one of them, we're going to say we're going to have a values to send, which is going to be dictionary, because I like dictionaries. Looping over these, we're going to say if, hey, scratch my new map, buddy. So what do we want to do? We want to, if the current state is different than the one in read pin states, then we want to add it to values to send with the new value. So cur value is equal to IO pins pin name dot value. If cur value is not equal to read pin states pin name, then values to send pin name is going to be cur value. So we build up this dictionary with all the ones that changed. Also in here we need to set read pin states pin name to cur value also. Right, we want to put it in the pin states so we can reference next time. We also want to put it in values to send. Then, once we're done looping, if length is an empty dictionary falsy? An empty dictionary falsy? D equals empty if D print truthy? Seems like it is not. Well, it seems like it is falsy. If not, print falsy. Okay, so we can just say if values to send, then print JSON dumps values to send. So one thing is we'll need to turn off a bunch of the rest of the prints, or else we'll need to how do we want to do that actually? Maybe we should say Maybe we should prepend this. Values, colon. So then on the other side, we'll look for this as the beginning of the message. And if this is it, then we'll split on the colon. We'll get the JSON, which will be to the right of the colon. We'll unpack the JSON, do whatever, all the stuff with it. This way, the rest of these prints, like all of this stuff, they'll get printed to the serial console. They're also going to get sent to the other thing that's going to be reading these things, though. The thing that's meant to be reading these are going to see all the print statements, but we can just ignore them if they don't start with this. So we see them, but we won't do anything with them. That's fine, I think. So we do this. Yeah, do we need anything else? So let's wire a button. Got a bunch of wires here. I'm gonna move these LEDs down and out of the way. I'm gonna move this closer. And I'm gonna have to pick this up because I don't actually know how the wiring on this works. So we have plus minus IAC. Minus. So I've only wired these up once. You know what, actually I'm gonna start with this switch first. This switch only has 2 wires. So we are pulling the input low. So we're gonna be connecting the input to power, 3 volts. So I'm gonna go, red wire is in 3 volts. Black wire is gonna go to IO pin, and it happens to be close, so I'm gonna plug it into A0. Now, one thing about CircuitPython, it's a little, I guess, different than Arduino. I don't know that much about Arduino. The pin A0 sounds like it would be for analog, but we can actually use it for digital as well, I think. Okay, so I have this switch running between 3 volts and A0. This is just a little, okay, we'll put this back in. It's gonna, I guess maybe I'll put it down here. It's just a little, flips like that, basically. Okay. We'll put that, so A0, so let's let it, oh, what is wrong here? Red? Expected? Parenthesis? Why is that? Did I mess up? Ah. This is a function. There we go. Okay. Makes sense. So let's put that back. Let's put this here. Let's run this. Invalid syntax 121. Did I save it? Yeah, I didn't save it. Okay, yeah, here we go. Now we're running. Okay, so let's make sure this works still. Pin D. Should make these be lowercase available. D5, 1. Turn the LED on. Ooh. Valid pin command. What did we break? I mean, it is one of those. Valid pin command. Ah, is in. Maybe we don't need is. Pin D5 1. There we go. Turned on the LED down here. And we could turn it off with 0. Turn it back on with 1. Okay. So for read, pin A0 read. Inside pin command value none reading true. Sounds good so far. And so the thing is, we didn't get the first reading, which is kind of a bummer. Basically, it's going to wait for it to change, I think. So I think it should have stored the current value in the read pin states, and it should now be checking the current value every time through the loop, and it will send it to us like this whenever it changes, but we did not actually get to read it the first time. Well, we read it, but it didn't print it out the first time. We didn't send it over to the other side of this equation. We'll need to figure out how to do that, but anticipation is killing me. Let's flip the switch and see if it does tell us. It did. So I flipped the switch and it changed to values A0 is true. If I flip it back, we get false. So now we can essentially send through the serial port a notification that says, hey, this pin that you told us you wanted to read up here, it changed value and the new value is false. So that's cool. But I would like it to send the first time. Let's how do we make it send the first time? I think let's what if we did not set What if we did not set the state? What if we said, set this to none? None. Then the value, which will be true or false, will not be equal to none. And it will send it the first time. I think, right? Seems right. Save this. So this restarts. So I'm gonna keep checking this to make sure I haven't broken anything. So our output works. Pin A0 read. There we go. We got false the first time. Yeah. And now, if we had two buttons hooked up, this would already support it. This would already send all the ones that change. So let's hook up this other key as well so we can make sure that's working. Other key. So I think it's plus and minus. I don't remember how they're wired. I don't remember how they're wired. Hey Keith, how's it going? Happy New Year's. Hope you're having a good day and good evening if you've got plans for anything fun. Let's look for, what is this called? Neo key? Neo key? Breakout? Oh, I just saw them. Yep, there they are. But what does this pin out? It's just plus minus, I guess. Oh, there's not a guide for these ones. So I want to say the IAC and OAC are for the NeoPixel, but that's not true, is it, I guess? So it would actually be probably voltage on plus, ground on minus, input output, which would be the NeoPixel pin, input on one side, output on the other side, and then Anode cathode maybe is what ACR. Doing well. Nice. Oh, bread in the oven. That sounds awesome. Yeah. Got some little cakes at the grocery store today. So I think it connects together anode and cathode for us. Is that how this works? Ah, there is a pinout actually. It is power, ground, IO is input for the neopixels. Yes, yeah, switch anode, switch cathode. We're going to be using a pull down. So we're going to put the anode to logic level power in 3 volts. Cathode will connect to the IO pin because we're using a pull down. Connect this pin to your microcontroller. It doesn't specify, but I think this is power pin, which would be 3 volts, and this will be IO pin. Okay, so we can have 2 wires, and it doesn't matter which side we go on, I don't think. I've got yellow in anode, and I've got green in cathode. And we said anode is going to go to power, which is 3 volts. I probably should connect 3 volts to the rail. And I can connect this switch. Oop. Oop, now we pulled it out. Okay, let me turn this off. Okay. Okay, so now we're on the rail. So now we can go, what was it again? Anode to the positive. Anode, yeah, to the positive. So we're jumped. We should have the rails jumped too, yeah. Put this back. To keep this, maybe I could scoot this back a little ways here. So we can go anode to the rail, and we can go cathode to the pin. Let's say we want to use pin 11. And 11. So now we should be able to go pin D11 read. It's false to start out with. And I'm going to press this, and we change to true. Release it, and we go back to false. Perfect. And this one still works. The switch. Yep, A1 is true when the switch is left, false when it's right. Okay, that's all working. D5 we can still turn on. Yep, excellent. That is honestly the majority of what we need right now, honestly. I think that gets us... That might be all we need. So now that we have this, we can have another program which will be sending these commands for us. And basically, we're going to be sending them from inside of Minecraft. Okay, delete these. One thing I never did solve for, I don't think, was like mixing and matching. Like if you set it to read initially, but then change it to output later. I don't think I handled that in this code, but I think for right now, this is fine. Really, my intention will be to kind of define ahead of time, I think, which pins will be inputs on which side and outputs on which side. So basically, for each I/O pin, you get to decide, like, is it going to input from the physical one and go from there into Minecraft? Or is it going to input from in Minecraft and go from there to the physical one? Pretty much each pin you get to decide that. I don't necessarily need it to change, like, during runtime. The user, I mean, it'd be cool if we ultimately could make it so you can, but it's also not so bad if you just set ahead of time, like, this pin is output this way, this one is the output the other way, so on and so forth. And this should be good enough for that. So I'm going to try to send, I'm going to work on trying to send these commands from inside of Minecraft, which is not CircuitPython, but is hopefully still interesting. I'm going to make a new command. I did figure out, Keith, I think it was you who stepped in for a minute last night while I was streaming. I did eventually figure out how to do the, put the torches on the wall. It turns out I just had the wrong block. There's a redstone torch, like regular, and then there's a wall torch, redstone wall torch. I'm going to make a test command called what? Well, it'd be cool if we could set this up where I had the same command essentially in Minecraft and it would forward it through. For now, though, I'm just going to hard code it. Command, I'm going to call this one just test pin. This is so big. Oh, this didn't stick. I can't scroll wheel this anymore. Oh, where it's frozen? It's frozen. Uh-oh. Is this frozen? Oh, this works. It's this one, huh? Well, that's no good. Restart it? I need to make a shortcut for this. Link download listener was failed. Yeah, can you stop or? I don't have a shortcut for this, so I have to launch it this way by going to the bin folder and running this shell script. And then if I accidentally close the terminal, what is this? Wait, we are all messed up here, aren't we? If I close the terminal, then it closes the IDE. What is this thing? I don't even, this is like Android, this is Android's. None of these work. I'm so confused. Close this. Go away. Go away. Doesn't want to go away. Yeah. No worries. I mentioned that I figured out how to put the torches on the wall last night. It turned out that it was just the wrong block ID, basically. I had redstone torch. Well, I can't open my... Oh, our project is still open back here. Did this never close? I'm so confused right now. Basically, I just had the wrong block type, though. There was a redstone torch block type, which I assumed is what I wanted, but there's actually a wall redstone torch or redstone wall torch or something. And that's the one we needed. So this is like, we're all sorts of dead here. X kill this. And this. X kill this. Okay. Not initialize. Get all that out of there. What does this thing mean? This thing... I don't trust this thing. I don't know why it's there. I don't want it there. I don't think it's gonna help me. Yeah, I was excited. So I think what I'll end up doing is spawning the torches inside those little holes where the pin cutouts are at right now. And then you'll be able to run your redstone dust like off to the side from there. Okay. Now we're back to good, okay. So yeah, like right here, basically I had redstone torch instead of wall torch. Apparently it changes to a different block. So did I break this by scrolling? Because I just did the scrolling thing again, and now we're frozen again. But this definitely worked the other day. Was that last night? This definitely worked when I did it the first time. Because I was like, man, that scrolling is super awesome. But now it seems like I'm breaking it. Action open file update, no Android SDK. Nothing like that screams like it would have gotten broken from scrolling, but we're definitely like just frozen now. Okay, no more scrolling. Can I run stuff? No. Let's kill. Oh. Oh dear. I don't know what that did or didn't do. Hopefully I didn't kill anything important. Okay. Alright. I won't scroll. I do think this is kind of small though. I feel like my other editors are bigger. I wish there was like IntelliJ or like JetBrains master config or something where I could have like one config and that would be the default for all of them. Okay, that's better. So I'm gonna go, whoa, what did we do? Why is this think? Oh, right. This has not changed yet. Command, test pin. Yeah, we don't care about anything inside the world right now, so we don't need any of that block stuff. We're just gonna say, open the serial port, send a message to tell it to turn on the LED pin. Which I will need jserial docs, I think. The name of the library I'm trying to use. This is all reading though. Yeah, this is not doing any outputting to the stream. I guess it's probably just write or write bytes. Get output stream. There is write bytes. Right up to bytes to write raw data. I think I want to use the output stream. I guess we'll go non-blocking. Not sure which one we want. Basically, when we run this command inside Minecraft, we're going to open up the port. We're going to right now just assume it's the first port. I think it will be. Maybe we should print something though. System out println opening port. Okay, yeah, this is back to Java land. Port. I think this was get. This is what we want. Yeah, this will be like /dev tty. Okay, open the port and just call write bytes, or well, open an output stream. So let's say output stream os equals com port get output stream. Yeah, can we make a buffered output stream? Yeah. EOS is new buffered OS. Yeah. Now we can just say That buffered would let me write a string. Java write string to output stream. Print writer. Or I'll get bytes. Why is it called print writer? Okay, so instead of this print writer pw print writer, okay, pw dot print, we print line? Probably. We need the enter on the end, definitely. Print writer, print line, pin D5, and it's currently on, so I'm going to try to turn it off to start with. Save this. Okay, we made a command. We need to register it in here. Test pin. Command test pin. Need to do anything else? I don't think so. Run this. I had to change the way I was building it to get it to build with the serial plugin. Hey there, GeoCouture. Hopefully I got the name pretty close. I had to change the way I was building, and what I noticed is my build artifact was no longer working correctly, which was the one that was getting put automatically into my Minecraft server folder. And so I ended up, there must be a better way to do this, but I made a Python script that copies the outputted jar into the Minecraft server. But what I noticed is that it runs, when I click run, I set it up to run that Python script for me, but it runs before the build. So it ends up copying the previous build into the server and then building the new build and putting it in my project folder. So I've been running twice to build it once and then run it again to copy it. Ideally, we would have something better than that, but that's where we're at right now. And I'm just glad that I can use the run button at all and get it to come out to the right spot in the Minecraft server. So we built that. Are we still running the server? No. Let's go here, terminal. Okay. Where's this? Okay. Start. How's it going, GeoCouture? You got New Year's plans tonight? You just hanging out? Okay, we're starting this up. I need to look into that paper server. Oh. Oh dear. I've never gotten this before. That seems bad, though. Wrong location. Chunk file is in the wrong location. Can't copy this very well. Spigot server chunk file is in wrong location. This site's killing me. I don't know why this site will not load for me in Firefox, and like it's like a Spigot Forms or something has all the answers to every question. Corrupted world. Region fixer. Well, I don't really care right now if anything is corrupted. As long if it will let me play. Although a lot of this stuff does look pretty messed up, doesn't it? What is all of this? We actually start the server? Oh, wait a minute. This is idea. This is not even the server. I'm not even looking at the right thing. This is the server. We did start. Something messed up though. Cloud for protection might be too aggressive. That's my guess. It's so weird that it somehow it works in Chrome versus Firefox though. I guess maybe Firefox. I don't know. I don't know why. What would be different? What is this? Yeah. So our new command did fail. Because the return value from get command string our first plugin.get command string is null. Command test pin. Oh. Yeah, we need to put this in here? Yeah. Yeah. Okay, this test pin. I'm gonna copy these. Test flip in state. It's not really what it does. I guess it always sets it to the low, but save this. We're gonna have to rebuild. Luckily it builds fast, which is why I'm totally fine just building it twice. I also figured out that you can... I keep reading this might not work for everything, so maybe eventually it'll screw me over. Oh yeah, see my here's one of the chunk errors. Took a big cutout of my feather here. Huh. I wonder what caused that. I should probably try not to let that happen once I actually build this, because I was planning on like going through and prettying it up some as well, like make the USB port silver, make the battery port black, you know, fill in these chips. This one's all messed up because there's holes in it, but I wonder what happened. Yeah, there's like part of it's over here by itself. This is like a little Picasso feather going on here. Interesting. Okay, well, really none of that matters for what we're trying to test though. So let's go land. So I also figured this out. Reload. We'll reload the plugins. Supposedly this doesn't work all the time, but it seems to be working for me, for the things that I've been changing. So we look in here, when we reload, we get a new callback to enable, and it reinitializes our plugin, including the new commands and stuff. So now we can go test pin. And if this works, then it will send the message to the feather, which will tell it to turn off the LED. Did not work. But it did not crash either, which is good. Okay, opening port, that seems promising. Oh, you know what? We already have the port open with TO. I guess we should save this. What did I change? Ah, I deleted the comment. That's fine. Yeah, let's save this. Let's Control TQ. Let's get rid of TO. You know what we're going to need to do is inside the Minecraft plugin, we should read from the serial and just print stuff out if we read anything. Because now I'm not going to be able to see the output from CircuitPython anymore. So I don't know when it happened exactly, but this did turn off. So yeah, this is tough though, because I can't... Maybe I should have made this turn it on instead of off. Ooh, maybe this should be 1. And maybe this should also close it when we're done. That way we could reopen it in TO and set it the other way if we need to. So let's run this again and run it again to copy it and then go back to Minecraft, reload. Yeah, this warning here says it might not work, but it's doing pretty good so far. So yeah, now we can run it and we'll see if it sends 1, which would turn the LED on for us if it works. No. But it does think it's opening the port. And it is the right port. Probably. So I wonder if it needs, like, is this flush? Do we need to flush this? The other thing is maybe we need the new line. I mean, print line, surely this would put a new line, right? That didn't change anything. This does make it tough, because we can't see if the CircuitPython script thinks it's receiving anything. So I did figure out also how to make a task that runs every so often. This one's currently set up to run every 10 ticks inside Minecraft, which it tries to do 20 ticks per second. So if it's running at the correct pace, this will be every half second, but I don't think it's guaranteed. So in here, maybe we can read from the serial port and print out whatever it says. So I don't really want the loop, though. Really what I want is, like, if bytes available is not 0, then read once, print what you read, and then that's it. We don't need this loop because we're already inside of a loop. Well, we're in a task that's going to run essentially in a loop based on the fact that it's repeating this thing. So open the port, check if there's bytes available. If it's greater than 0, then try to read them. I don't know, we're gonna need to get a string out of it eventually. Read buffer. This is creating a byte buffer this size, num read. Read bytes, read buffer, length. Bytes from com port. And then either way, close. So each time this runs, open the port. If there's more than 0 bytes, then read them. Right now we're just printing the length, but eventually we'll convert this to a string. Close the port either way. If there were no bytes, then we don't go inside here, we just close the port. Okay. Let's try this. You know, I bet you the corruption might have come from idea getting stuck, how it was. Because I bet you the server was running inside the terminal the same way that I have this one here. I bet you it was like, it was running and then it just freaked out because it disappeared or something. So we sent that. Still not working. We didn't actually see anything else ever get printed. Okay. So this one is always saying 0. Bytes available is never more than 0. But would this even be working? So let's go back to here. And then let's just say print. Let's make it change. Print TikTok. Let's do this, that way it'll change every time. So now it should spam the serial, which we should be able to see from this side. Because it should have bytes available more than 1. Would it work to open the port, sleep for a period, and then see if there's anything in the queue? Possibly. This is really the first time I've ever used this, this serial port thing. Oh. Hey, what? Read? We got one. We got read 19 bytes. But... oh yeah, now we're getting them. We're getting more. They're sporadic though, right? Shouldn't it? It should be... like it should be more consistent than that. Because like if we kill the server, let's kill this. And watch here. Yeah, we're just constantly, like super fast, we're printing this. Hmm. Okay, let's try to print the message that we actually read. So we have a byte buffer and we need to make it a string. Maybe we should be using the input stream? Here we're just calling read bytes, but when we write, we're using the output stream. I wonder if we should be using input stream. I mean, surely this is just opening it and writing to it. I think. Yeah, so let's try to convert this and just print whatever is actually coming through so we can see if it's even a print statement or not. Java convert byte array to string. What do we got? We need like tell it UTF-8 new string bytes. Coding. New string. Standard char set. Read buffer. Standard char set. Okay. We'll print the number of bytes, then we'll print the actual string. Save this, build. Build again, copy the latest one. Let's make sure TO is closed, yes. Start the server. Whoa. That reload thing is awesome, because we don't have to wait for this every time. Although, there is that warning that says it might not work, so maybe we shouldn't trust it too much, but so far it seems to pick up the changes that I saved. Okay. It is. It is what we're sending. It is what we're sending. So let's turn, but it's so slow. It should be coming through. Well, but we're at 2 times a second. But I mean, it should be. It must be missing some? What is the. Yeah, we're missing some because we have 57, 55 here and then 60, 55. So 3 seconds later. But we saw in here, this is going very, very fast. Like 6 times per 100th of a second here. And then this time we had 6 seconds in between. Interesting. I wonder why we're skipping some. We don't have TO open. We don't have another one? No, we don't have mu open. We're not connected with any other thing to the serial port. Okay, let's make it not spam as much. So let's turn this one off. Build. Did I build twice? I'm not sure. Build again. Doesn't take that long. Oh. Why'd the server die? Well, this thinks the server's still running. Huh. That's interesting. Okay. So we reloaded. We're no longer spamming. We're also no longer printing. We're not even getting one every few seconds. Huh. So for some reason, spamming... I don't see why... What is that? Oh, I have this open still. Let's close that. I don't see why spamming would make us more likely to read something. Now we're not getting anything. Something is wonky here. We got one finally. But only one. I guess they're disappearing or something. Like if we don't read it at the right time, it goes away. It's like they're not queuing. So like we have to get lucky and read it like the exact instant that it comes in or something. Which I guess kind of makes sense, right? We're closing the port every time. So like the port's spending a bunch of time closed. Yeah. Okay. So we need a different paradigm than this. We can't have one-shot task, open the port, read, print, and then close the port. We need to keep the port open throughout the life of the plugin, and then in this task we would just read and print, but not open and close. So what if we, for now, I don't know how we would get a reference to it in our command. Does this have a plugin? And executor, is there a plugin? There's, So I don't, if I have it open inside of the plugin, I don't I don't know if I can then open it inside of this other class. I guess let's try to solve one thing at a time. So if we open it inside of onEnable and we close it inside of onDisable and we make it a variable that has more scope like this, now it gets opened once, closed once. I'm going to turn the spam back off. Yeah, let's try it like this. So if this spams our TikTok and our time.monotonic more frequently, then we know that this will be the solution for skipping some of the reads. Not looking good. First, we still might have the same core problem of like, if we don't read it at the exact right time, do we miss it? It's almost like it's not being put in the queue. Try sleeping for 0.1 seconds. Back when we were opening it here, or when we do it during enable? Let's turn the spam back on. It's so weird that that's making a difference. I'm also not sure back when, okay, yeah, when it was opening and closing together. Okay, that seems weird. Why would we get -1? We were getting 0 before. So when and why does this... Turn a number of bytes available without blocking if read bytes long were to be called immediately after this method returns. Number -1 if the port's not open. Or port's not open. Maybe we need to actually do a real restart the server and not a fake reload command. What are we trying to do? Hey, how's it going? Bad? Is it Bad Abby? Yeah, let me build this real quick, and then let me start this, and this will take a minute to start up anyway, and I can explain what we're looking at. So, to start with, I'll show you this. We have this feather that I imported inside of Minecraft, and the goal is ultimately to hook up this virtual feather that is inside Minecraft and then make it so that all of these pins that are on the virtual feather basically sync to a real physical feather that's plugged into my computer. So I have this feather plugged into my computer, and I want it so that the pins sync back and forth. So we have this LED currently plugged into pin number 5, and so I want you to be able to go inside of Minecraft, put a lever or any kind of redstone switch contraption, anything that can, generate a redstone signal, and you hook it up to pin D5 in Minecraft to that feather, and then you flip the switch on it, or you make the redstone signal turn on, and then it will turn on this LED. So that way, you know, you're controlling the physical circuit from the redstone circuit inside Minecraft. And I also want to be able to go vice versa. So we have a key, just a regular cherry key. We also have this flippy switch here. I probably just unplugged again. This little flippy switch here. And so this one we would be able to, you know, use the physical circuit plugged into the actual feather and have that control the redstone circuit. So you could flip this physical switch on and it would turn a redstone signal high, so you could use it to turn on a contraption in the game. Exactly right. Yep, that's exactly right. So we just created this little very, very basic serial commander where I can send it a command like, which I should really have documented here anyway, so let's do that. Well, yeah, okay, let's just do this. Example command. We can send it a command like pin space D5 1, and that will tell it to turn pin D5 on to high. And we could send it pin D5 0 to turn it back to low. And then the other thing we can do is pin, you know, like D4 read with an R, and this will tell it to start reading the value of that pin, and then when it changes, that's when it will try to send it back over to Minecraft so that Minecraft could know the current state and make a decision based off of it. And so that part is all working. The serial command is working pretty good, and I was trying to get Minecraft to send the command, but that's essentially where we got to, and it seems like we're getting always that thinks the port's closed. Yeah, we got -1 all the way through. So I wonder if on enable is returning down here, and maybe that is like letting comport get garbage collected or something. Oh, I never opened it. Oh my gosh. Okay, yeah. Gotta open it. That's probably gonna help. I bet that's gonna help. Okay. Yeah, Java's a lot of fun. I like Java. I haven't done a whole lot of Java Minecraft stuff. Done a bunch of Android, which is all Java code. I can't believe I didn't open it. So I copied this command, but I never actually called open on it. Do you need to, though? Was this? Yeah, it had open right here. I just didn't copy it. Can't believe that. And I don't have open here anymore, so. Oh, come on. Okay, so save this. We ran it, it moved. Server died. I'm gonna actually just kill the server. All right, we'll restart this again and see if we get anything. Yeah, fingers crossed. And I probably also won't go for too much longer. Gonna hop off and hang out with the wife, find something to watch, eat our little cakes. Still need to eat dinner. But I do kind of want to see this flip the pin once. I would really love if we could get like one successful pin flip. And let's be real, if we get one, we're probably going to go with a couple. So It'd be super cool if we could get it to actually go all the way through and flip the pin. We don't have it all hooked up with like redstone and stuff like that yet. Right now I just got it hard-coded sending the command, but okay. Yeah. Much better. We're getting spammed a lot now. So our COM port's always open. We're always reading. We're seeing probably everything that's getting printed. I don't really have a way to verify that that's actually everything that's getting printed, but it's definitely multiple per second. Lots and lots, like 10-ish per second, which is more than enough for what I need. So, but now the problem is we opened the COM port inside of the Java plugin, but our thing where we're trying to write to the COM port is actually in a command. What if we just cheat a little bit for now and say we make an inner class public, pretty much just this. Yep. So it's gonna be mad because we have 2 copies of this. Maybe we can comment this one out. I don't know if that's gonna make it happy, but okay, so we're gonna put all this stuff in here. Yeah, well actually we tried to do that, actually, if you notice right here, but yep. Okay. This is mad. Oh, it can be static? I don't think it can really be static, but thank you for looking out. So we're gonna basically... This is the wrong stuff. What did I just do? Yeah. Okay, we need to undo this. We don't want to comment this. We want test pin, not spawn pin. Spawn pin was a different test. Not to be confused with test pin. I should probably come up with better names. This is what we want here. So we already have the port. We already have the port open. So we're just going to get the output stream, make the print writer, call the print line, call flush. We don't want to close the port. We do maybe want to close the print writer and thusly the output stream. I assume would happen automatically, but I don't actually know. Oh, yeah, it doesn't. Oh, there's an exception. Let's just close the writer for now and see if that gives us trouble. So now this is an inner class, which means we can access COM port. That seems better. So now the question is, when we register this, does it know, yeah, that we're going to the inner class? Perfect. Okay, so save this, run this. One more run to copy the new one. Terminal. So we are still running the server. One thing I'll do is let's turn off some of the spam, but let's do it from the microcontroller side. So let's just say here we don't want to print this anymore. Save that. Perfect. Yeah, we're totally seeing all of our stuff come through. Did we turn back on the spam inside of here? We did. I guess it was going so fast before that I wasn't seeing these. Okay, let me do this one more time. Run this. Like, ideally, I just want prints when something actually printed from the Python side. Okay. So now we'll see if a reload works for us. I think if we reload, we'll get the new plugin, which means we won't be spamming that 0 bytes available. But when it does actually print, we should see it say something. So like I'm gonna just push the reset button, I think. Put this over here. So I'm just gonna push the reset button. Oh, but the problem is this will not reconnect. Yeah, that's a problem, huh? Yeah. Okay. So that's not what I should have done. So, let's reload this again. Because this should make it reopen the serial port. And then I guess let's just try... Let's just try... What was it? Test pin? Okay, so... Did my circuit come disconnected? Are we? No, we're solid there. We're on pin 5. So... We did not see this. So it's almost like we stole it from the other side. It's almost like we wrote... I think we wrote to it here and then just immediately read back what we wrote right here. But why did it not go to the other side? So maybe print line does not actually do new line, and maybe this actually needs to be this too. Let's try this. This is the answer a lot of times with serial protocols. I feel like we're so close. Okay, we ran that. So here's the problem with reload. Does reload call disable? Okay. There we got it. Okay. Yeah. We got 2. We never sent it before. I think we never sent it before. It was still sitting there in the... I mean, I guess there must be a buffer on the CircuitPython side. It was still sitting there in the buffer on the CircuitPython side waiting for a new line. And then once we finally give it a new line at the end of this one, it worked. But it read the whole thing. So it might just work, right? I think if we send it one more time, it will work. Yes! We did it. Okay. Sweet. Yeah, that's awesome. Okay. So we basically have all the parts we need. Obviously, we still have a couple of things to hook up, but we have the microcontroller that will turn on and off for us. It will also give us the readings. You know what? One thing maybe we should try real quick is let's do a read. Let's do a read and make sure it comes through. So instead of pin D5-1, let's do two things. Actually, I'm feeling good. It's New Year's. Let's do two things. Let's say this and also another one. Pin. What did we hook up? The cherry key was D11. D11. So let's go D11 read. Whoops. Read. Whoop. Read. There we go. So output D5 high, and then set D11 to read. I almost want to change this actually to low. Eventually, it'd be cool if we could accept another command. I'm pretty sure Minecraft has the ability for us to be like test pin like 1 or 0 here, but I don't actually know how to do it. And since my light is on now, I want it to change. So we're going to set it to off. We're also going to do the read. So I'm going to build this. We're going to build it again to actually copy it to plugins. Then we're going to run reload. And then when we run the command next time, it should turn the light off, and it should start reading D11. Oh, reload. And then we should be able to see it come through to the Minecraft server logs when we press the button. So that's our reload. Let's get this. Go back here and here. So we go test pin. Whoop. I figured out this double slash is a problem with GNOME, I think. The Linux like desktop thing, GNOME, which happens to be what my computer uses. All right, so that turned it off. We got the first value right here. Values D11 is currently false. And so now if I press the button, it's going to change to true. Send it to us. It's not looking like it though. We got the first one. That's pretty good. I don't know why we didn't keep getting them though. It's almost like we got a nothing here. Is this still wired up right? So we're on power on the anode. This is 3 volts, jump to the rail this way. That's definitely on the 11. Why would it not be changing? Oh, Discord chat is blocking the LED, my bad. Need to try to remember to scoot this towards the top always. Do I have the CircuitPython code checked into my repo? I do not, but I can share it. I'll make a gist real quick and share it. I will make a repo eventually. Let's go lowercase. There's that. This is the code that's on the CircuitPython side. I'll publish the plugin side as well eventually once it's working too. This is weird though that it doesn't change anymore. I wonder. Let's do the switch one. A0. Let's do A0 instead of D11. And I guess let's put this back to 1. My only guess, well, no, because we sent it correctly because it did get configured. We just never got anything else after that. Theoretically, pin D11 is still just sitting in read mode, waiting for changes, but for some reason we're not noticing the changes. So we ran that stuff. Oh, this says, what does iSearch mean, I wonder? We have different stuff here now. Okay, reload complete. So we went back to on, and we set read mode to A0. Our first reading was true. Shouldn't matter if this is paused or not, because this is running on the server. I'm going to flip the switch. Yeah, we're not getting the changes. Wonder why we're not getting the changes anymore. Well, this is not plugged in all the way. N is plugged into the wrong spot, actually. Well, let's try to fix that. Still doesn't do anything when I switch it. Okay, so I'm gonna close out of here. I'm gonna kill the server. I'm just gonna go back to TO and see if it seems like it's behaving correctly. And then honestly, I'll probably call it a night after this. TO. So I'm not gonna do anything else. I'm just gonna switch it right now. Yeah, it's not printing. Okay. So that's actually a good sign. So I noticed that I just pulled it up again though. Maybe it's just not staying plugged in right? Okay. Wait, it does not want to stay in at all. Yeah. Totally agreed. And I think everything on the Minecraft side is working. At this point, this is actually good news because it means something on CircuitPython side is broken. So let's just restart this. Restart. And then let's just sanity check some of this stuff. So pin D5 1 probably works fine. Yep. 0 works fine. So then let's say pin D11 read. Okay, we got values false. I pushed a button, we did get values true. That seems to be working. And A0, which is the one that the clunky switch is on, also works fine. So why would those not be coming through when it's running? I wonder if it got in a broken state when I had that double command. Maybe that had lasting effects that broke it. So let's just try reset this. Close TO. So we know both of these are wired right. I'm going to go back to D11 because that's more convenient. Build this. I'm going to give it one. We're going to give it one more try, and then I'm headed out. Build this. Terminal. Start. This is really weird. that it seemed to get the read mode sent over correctly, but then just stopped actually checking it. I guess is that double command messed us up somehow. That's what I'm gonna hope at least, because if that's the case, then it will work this time, as long as I don't double command it again. This is awesome though. I feel like we're so close. We have really all the major components we need to bring all this together. And they're all kind of individually working in their own proof of concept way. It's now just like get the glue between them all. I wonder if there's a way I could tell it to just not bother making the nether in the end. If I'm never going to go there, then I'm just waiting for extra time. Yeah, thank you. Okay, so we're going to log in and connect, join. We'll just run test pin once. It will turn the light to on. I'm actually going to go time set day. I need to figure out how to make this always stay day. Okay. Test pin. So turn the light on. It's set D11 to reading. Current value is false. Pushed it and nothing happens. Alright, well. I don't know what... Don't know what could be causing that, but we'll have to troubleshoot it a different time. But we got the writing working, seemingly. One thing that'll be cool is when we can get this command to be able to take a 1 or a 0, and then we can just flip it back and forth without having to change the hard-coded value in here. Ooh, that sounds promising. Daylock. True, maybe that's like an add-on thing or something. It's interesting, it doesn't like tell me that it was an invalid command or anything. I don't know where the sun is up there. Can't tell if it's moving still. This is the Java version. This is the... So I might mess this up. I don't really know that much about how all the different pieces work together, but I believe this is the stock Java client, the vanilla Minecraft client, you know, as distributed by Mojang. That's my client, and then my server is a Spigot server jar, which is not directly... It's not the vanilla server. It's not the one released by Mojang, but instead it's the Spigot server, which adds on to the one released by Mojang. Hey, how's it going, C. Grover? Might not be the command Google freezing day cycle. I think this command isn't supported. Yeah, it seems like it's not telling me that the command's not supported, but it doesn't seem to like acknowledge that I did anything. I know one way I could do it, because I know, like, I keep doing this, time set day. You know, one thing I could do, I guess, is like, oh, I don't know how to get a command block. If I gave myself a command block, and then if I used this thing, I could make a daylight detector, and then make a negate circuit, and then, like, whenever it's not daylight, it could send the command for me. That's convoluted, but it could work, maybe. But I'm sure there's probably some kind of command. I just got to find out what it is. But anyway, we're pretty close. We got individual components working. We were able to flip the LED on and off, which is sweet. Yeah, that one, game rule, that actually rings a bell. That does ring a bell. Game rule. Yep. Yeah. I think that one's right. Yeah, I think the sun's not moving anymore. I let go of the mouse and I'm not seeing the, well, I can't really use the mouse to point, but before I was seeing the little lines move, like how the clouds are doing now. The clouds are still moving, but the sun is still. So I think we did it. So thank you for that. I appreciate that. But yeah, we got the LED flipping. Next time I'll work on the command to be able to send 1 or 0 instead of hard coding. And then we'll try to troubleshoot what's going on with the reading. Seems like we're getting the first read, but then not any others after that. So we'll have to figure out why that could be. But it seemed like it was working when I took Minecraft out and just ran TO. So maybe something to do with the way we're reading or writing is changing it. But yeah, I don't actually know for sure. I might stream for a little bit tomorrow. But I can't really commit to it, truthfully. I don't know what all is going on tomorrow. But ordinarily, the time that I stream, folks will know, is Saturday mornings, morning in my time zone, Central US time at 10 a.m. is when I generally stream on Saturdays. Tonight, again, to recap, we were filling in for a deep dive, which is usually Scott's stream. I believe Scott's back next week. I don't know for sure, though. We'll have to check with him. But I think Deep Dive is back next week. If not, then maybe I'll stream on Friday night again. But most likely it'll be Scott next Friday. And then I should for sure be streaming on the 8th of January. So next Saturday. I might pop on for a little bit tomorrow. Truthfully, I'm stoked about the progress that we have on this. So I might stream a little bit tomorrow and work on this again because I want to get it working. Really excited about it. So maybe we'll do that. And that'll start at 10 a.m. But I don't know if I'll go the full time. Might be a short stream. But that'll be, I think the plan is I'll be back at 10 a.m. tomorrow, which is, what is it? 16 and a half hours from right now. But I might be off by an hour, so maybe it's 15 and a half hours. I think it's 15 and a half hours from right now. Whatever time zone you're in. I think it's 15 and a half hours from right now. But either way, it's 10 a.m. Central, which is usually what I call it. So if you convert that to your time zone, then that's what time I'll be streaming. So I'll see you folks then. Thank you, Keith, especially for that command. That's super helpful. I really appreciate that. And thank you as well to C. Grover and Bad Abby and anybody else who followed along. And I hope everybody has a good evening and Happy New Year. Have fun. Hope everybody stays safe tonight. Have fun, and I will catch you next time.